Hey guys, welcome back to another video. Today we're looking at the following geometry problem from Math Counts. And so let's start as always with a quick read. So right triangle ABC has AB equal to AC equal to 6. Let's zoom in a little. Circular arcs are drawn with centers at A, B, and C, so that the arc centered at A is tangent to side BC, and so that the arcs centered at B and C are tangent to the arc centered at A. So what is the area of the shaded region inside triangle ABC but outside the three arcs? And they're asking us for a decimal to the nearest thousand, or nearest hundredth. Okay, so this type of question, it's clear that the shaded region, we can't solve for it directly. So we're gonna have to find the area of triangle ABC and then subtract off the areas of each of the arcs, right? So each of the arcs, so let's call the arcs arc A, arc B, and arc C, right? So like this is A, obviously it's in that A, and you have B in the top corner and then C in the bottom right corner. So, and I guess the appropriate term would not be arcs, but actually sectors, but the idea still stands. But anyway, so if we start with finding the area of triangle ABC, that's not hard, right? It's a right triangle. So we already know the area is half times base times height, which is half times 6 times 6. So 18, right? It's just because base AC, height AB. So 18 is our area. And now we want the area of the sectors. So if we start with, so let's write 18 here. So now if we start with the entire, let's start with A, right? We want to find the radius of sector A, right? The arc centered at A. And so to do that, we draw this line in here. And now this line that we drew has length 3 root 2 because it's the median to the hypotenuse. And basically, we could see that this angle right here, shaded, and this angle are both 45, right? Because basically, if we call this point D, the line that we just drew, triangle ADC is similar to triangle BDC, right? And the ratio is root 2 to 2, right? Or you could say 1 to root 2. And because basically you just have a 45, 45, 90 triangle where the hypotenuse is root 2 times each of the legs. So ultimately, you know AD is 3 root 2. So that means that this is 3 root 2, the radius of arc A. And we also know, because AB is 6, then this smaller radius right here is 6 minus 3 root 2. Okay, so now that's important to keep in mind. But if we first start with the area of sector centered at A, you basically have, so pi r squared times, it would be 90 over 360, right? Because we basically have the angle is 90. And so the way to find the sector area, if you might not remember, is just the total area of the circle, which is this part right here. And then you just take the fraction, what fraction of the circle it is, right? So the sector goes, it has a central angle of 90 degrees. So you have pi r squared times 90 over 360. R is 3 root 2, so we have pi times 3 root 2 squared times 1/4. And so this is, if we multiply this out, pi times 18 over 4. So that's 9 halves pi. Okay, so this is the area of the bigger sector A. And now we have these two small sectors, right? So the radius we already know is 6 minus 3 root 2. And then the other piece of information we need is the angle. That's 45 degrees, right? They tell you, well, we basically know this is an isosceles right triangle, so the ratio is 45, 45, 90, the angle ratios. So that means if we do the same formula, you get pi times 6 minus 3 root 2 squared times, and we could say 45 over 360, right? But we know there's two sectors. There's two identical sectors, right? If we shade it, it's basically this sector right here and this sector, right? So we could multiply this by 2 at the start. And all that does basically is says we have basically pi 6 minus 3 root 2 squared times 1/4. Okay, and now if we expand this, right, it's just a little bit of calculation. Keep the pi out for now. We have 36 minus 36 root 2 plus 18 times 1/4. Okay, and we just check over our work. Yeah, okay. And then now simplify the inside of the brackets. You get 54 minus, 4 minus 36 root 2 over 4. So that's pi times. So now 5/4, or 54, would be 27 over 2. And then minus 9 root 2. So this is what we have. Okay, and now if we add up this sector area plus the 9/2 pi we found right here, we basically get pi times 27 over 2 minus 9 root 2 plus 9/2 pi, right? And this is, so if the 9/2 and 27/2 come together, and you get 36 over 2, which is just 18. So you get 18 minus 9 root 2 pi. So this, if we go back, this is the area of the sectors. And as we said, we want to find the area of the triangle and subtract off the area of the sectors. So if we finish up the problem, we get, find this, we basically have 18, we found was the total area, minus 18 minus 9 root 2 pi, right? And this would be our final answer. And it looks pretty ugly, but you are allowed to calculate a calculator on this question. And they ask you to find the answer of this problem to the nearest, they said 100th, right? So we basically plug in 18 minus 9 square root 2 times pi, and you get your answer of 1.437. So we get, let's write that down, 1.437, round to the nearest 100th, 1.44. And that is our final answer. So if you have any questions on how we solve this, please leave a comment. And if you enjoyed the video, like and subscribe. It really helps us out. But that should be all for today. So we will end for now, and I'll be back again tomorrow with another video. Thanks to everyone for joining.